this episode we'll look at melanoma. It's known as a great mimic of other types of malignancies and can cause quite a lot of differential diagnostic problems because of that. All of the cases I'm going to show you are from lymph node, but melanoma can present in almost any cytology specimen, and the features I'll talk about are generalizable to those as well. As usual, we'll look at arrangement, cytoplasmic and nuclear features and how they're expressed. So because melanomas are not carcinomas, they're not epithelial tumours, they tend to present usually in a fairly dispersed pattern. And this is a classic example here. We've got a whole lot of basically single cells. So on high power you can see they're sort of touching each other perhaps, but not actually growing together and certainly not forming a cohesive community sort of border like an epithelial cell. This is another example, and the cell borders are a lot vaguer in this, but you can still see that they are fairly much singly arranged. They're sort of clustered together a little due to the smearing, but mostly the cells are just arranged out on their own. This one has quite a bit more nuclear variability. This is the sort of arrangement you might get that is a little more cohesive in melanomas, and this is what we would call sort of loosely cohesive groups. And the cells are sort of piled together, again not really forming any structure, not really organised, and not forming a community border. This is another area of the same slide, and you can see mostly the cells, same sorts of cells, are arranged in a fairly single fashion. Another specimen, and this one again is mainly single but with some loose groups there too. See how they're just sort of very disorganised in the way that they're piled together on top of each other, not actually kind of really growing together, but are just loosely adhering to each other. The cell shape varies enormously. So the most common pattern is like that first case, this one that we were looking at, and this is a plasmacytoid appearance. So the cells are plasma cell-like. They have a round nucleus in an oval cell that's polarized to one end of the cell. This is what can occur often as well. So this one has a little more cells that are more elongate in shape. That can vary up to this sort of pattern, which is really what I would call a spindle cell pattern. And by that I mean cells that have a cigar-shaped nucleus and a bipolar, strung-out cytoplasm. So nearly all the cells here are quite elongate. Some of them are really quite cigar-shaped. This is the pap on the same specimen. And you can see the nucleus goes right out to the edges of the cytoplasm in these true spindle cells. So this spindle cell pattern is really more of a sarcomatoid pattern, but you can see it in squamous cell tumours as well. Here we're looking at pigment, and in the diff-quick it tends to be this blue-black colour. Notice how some of the cells are intensely pigmented, some just have a fine dusting, and some won't have it at all. And the paps, this stains a sort of golden brown texture like sun, as they say in the song, or else a very dark brown. And so it's quite a bit like hemosiderin sometimes. You can see how much of it there is in this specimen, and this one here has a lot of it that's quite intensely almost black. And sometimes the specimens macroscopically have so much that you can see them look black when you aspirate them. Having said that, about half or more of cases of melanoma in cytology specimens will have no pigment visible. So nuclei are quite varied. Sometimes they're reasonably uniform, but they may show a lot of anisokaryosis and may show really bizarre forms as well. As I said, the shape of them, like the cells, varies a lot. This is that plasmacytoid pattern again, and notice these are fairly uniform round nuclei, and not a lot of variation in size, a bit of binucleation in there. This one's showing an enormous variation in size and shape. There's a huge nucleus over there. Notice how many binucleate cells there are in this field as well, and a lot of anisokaryosis. So this is a really easy diagnosis to make of malignancy, and some of the most bizarre, weird malignancies you see are melanomas. There's a really huge one. This is what we call a bug-eyed demon. It's a binucleate enlarged cell with nuclei that are sort of right out in the periphery of the cell, and they have a very prominent nucleolus in them. Makes them look kind of like some sort of insect. And that's a common finding in melanoma. This is one on the pap stain. These are very occasionally seen in other types of tumours, so they're not entirely specific, but they're just a common feature. These are spindle cells again. You can see the nucleus is quite elongate in these and quite cigar-shaped in some of them as well. Notice how the nucleus goes right out to the edge of the cell in these true spindle cells, but there'll be a gradation from round cells through to those elongate ones. This is a bizarre case, and it's showing a feature that's quite common in melanomas, which is intranuclear cytoplasmic inclusions. These appear as big vacuoles inside the nucleus, and there's some really quite large ones in a lot of the nuclei that are present in this specimen. Notice how much pigment there is around as well. Another binucleate cell. And notice how prominent the nucleoli are in these cells as well. They're really massive. Often they're large, single and central. This one's got quite a few that have multiple nucleoli. So the differential diagnoses with melanoma are wide and varied. Because of the wide variation in morphology, from spindle type cells through to plasmacytoid ones through to very bizarre ones, the differential diagnosis can include anything really from sarcomas through to spindle cell squamous cancers to poorly differentiated epithelial tumours to lymphomas even. Probably the most common, in my experience, differential in FNAs especially is with metastatic adenocarcinoma. So sometimes adenocarcinoma will appear very similar to that plasmacytoid case I just showed you, with a more dispersed population. They will have cells that are, again, plasmacytoid, so an eccentric nucleus. They'll also have prominent single central nucleoli, just like melanomas, and it can be quite a difficult differential. Obviously, to confirm adenocarcinoma, we'd be looking hard to find cohesive, truly cohesive groups, and probably vacuolation in the cytoplasm. But as I say, the differential can be very wide and will usually require immunohistochemistry to prove the diagnosis. And that's particularly true because melanoma can present without a known primary, and also within bizarre sites, often with patients who may already have another primary tumour known as well. So confirmation is always important.